Next is all about our expert R, the influence of particle size distribution on the characteristics of powder coating. Mr. Kuldeep Verma ji. So I would like to invite Mr. Kuldeep Verma ji on the stage और हम थोड़ा सा आपको कुलदीप वर्मा जी के बारे में बता देते हैं. So Kuldeep Verma ji did his B.Tech in Paint Technology from HBTI Kanpur in 1989, then worked with companies like Hardcastle and Wood MFG Co. Rapid Engineering Paramount Powders, UCI Coat Saudi Arab Sharp Coating Private Limited, and now he is in having own companies, that is Torix Chemicals Private Limited and Sai Consultancy. Total more than 35-year experience in powder coating production. Oh my God, more than 35 years. तो एक बार जोरदार तालियां हो जाए कुलदीप वर्मा जी के लिए. Come on everyone.
टॉपिक तो हमारा ऐसा है कि इसमें टाइम बहुत लग सकता है, बट हमें 20 से 25 मिनट दिया गया है. सो आई विल ट्राई टू कवर ऑल. दिस इज अबाउट माई सेल्फ. सो दिस इज इंडियन पाउडर कोटिंग मार्केट. रफली अराउंड 15,000 tons per month, and polyester resin 2,000 per month indigenous, and around 7,000 tons imported. These both are using, and there is a big gap between Nerolac and others. Nerolac is doing very well. Maybe this is near figure, not exact. Maybe 100 tons more, 100 tons less, like that. So my topic is particle size जो पाउडर ACM यानी एयर क्लासीफाइंग मिल से ग्राइंड करते हैं, उसके पार्टिकल साइज का क्या प्रॉपर्टी पे इफेक्ट आता है. सो पार्टिकल साइज, इट इज़ द होल पाउडर इज नॉट ऑफ अ सिंगल पार्टिकल साइज, इट इज़ अ पार्टिकल साइज डिस्ट्रीब्यूशन. सो affecting application efficiency, film quality, final performance. The narrow medium size particle size is better flow, uniform thickness, and optical mechanical properties, while very fine particles can cause the clumping and mishandling. The very fine coarse powder can give a poor flow like orange peel. The powder coating, typically the particle size should be from 10 micron to 100 micron. This is a range. The major particles should be between 30 to 50 micron. This is data. The max optical range should be 30 to 50. But definitely there are some 5 micron, 10 micron, 80 micron particles are there. This is a graphical representation. D50 means D10. 10% of the overall particles are below this particle size. And D50 is 50% of the powder is below this particle size, like D90 and D99. This is broad distribution, means it is having very fine powder, very coarse powder, optical particle size also, but this is not good, because very fine powder, when during application, the powder overspray will be more. Can we have a video, please? Please start the video. This is a video on Melbourne particle size. वीडियो स्टार्ट करा दी वहाँ से. हाँ ठीक, ओके.
The Master Sizer 3000 is the world's leading laser diffraction particle size analyzer. It has been developed not only to enable robust and rapid particle size measurements over a wide 0.01 to 3,500 micron range, but also to bring Malvern's application knowledge and expertise right next to you in the lab, enabling you to develop and run your methods efficiently. Reproducible and reliable particle dispersion is ensured by a wide range of sample dispersion units, which enable the measurement of dry powders, suspensions and emulsions. The Mastersizer 3000 system and its software has been designed to make method development easier.
This is basically on
During method development,
making
the
slurry,
Mastersizer
but now
3000 measurement manager
instrument is also
provides a
available
view of
for the
everything
powder
you need
itself. It
to
will come.
understand and optimize the measurement process. This includes controls for the dispersion unit, live reporting of the data being collected by the system, trending of the results, and a simple view of where you are in the measurement process. Method development requires a user to select the optimum dispersion settings to achieve stable, reproducible results. Live feedback of the dispersion process quickly shows when the sample concentration is suitable for measurement. The process of sample dispersion during stirring and the application on inline sonication can then be followed within the measurement manager. This shows the decrease in particle size, which occurs during dispersion, until the size stabilizes and there are no more agglomerates. Once stable measurements have been obtained, a clean sequence gets the system ready for the next measurement. Although wet dispersion is widely used for measurements, the real benefits of rapid measurements with laser diffraction are best realized with dry powder measurements. Switching from liquid to dry dispersion is easily achieved by simply changing the Mastersizer 3000's measurement cell. When this occurs, the software automatically detects that a new sample type will be measured and configures the system ready for dry dispersion. Dry measurements offer the ability to quickly measure larger volumes of sample. The sample tray and hopper can be configured to control the flow of different types of material.
There is
Other
no
sample
liquid,
trays are
nothing
available
is required,
to
only
handle
solid.
smaller sample volumes. As with liquid dispersion measurements, the Mastersizer 3000 Measurement Manager is used to guide you through the dry measurement process. Once the sample feed starts, the software automatically triggers the measurement. Live reporting of the results is then provided, so you can be sure that the measurement is operating optimally. The measurement runs until all of the sample is measured, ensuring representative results are obtained. Once the measurement is complete, the results can be displayed within the software's record view. Here, any number of sample reports can be stored, enabling you to report the particle size parameters which fit best with your application. From research and development through to routine QC measurements, the Mastersizer 3000 is the workhorse particle.
Now, this is effect on application. As powder is being used, so इसके particle size के क्या-क्या effect आएंगे उस पर? The fluidization and flow. This is not the pure film flow. This is free flow properties. So, a well-controlled particle size distribution is there. The durability, the powder fluidization in the gun hopper, it will be better, and easily and consistency can be done. Then handling, very poor, good, handling will be very good. Then transfer efficiency. The most of the powder will transfer from gun tip to the application, the substrate. The effect of coating properties, this is on the cured film. So the film formation, the mix of the fine and coarse powder optimize, it gives the better film, the smooth film, because some fine powder is also required. Then mechanical and chemical resistance, because when the film is smooth, there is no pores, so chemical and mechanical properties will be better. Then uniformity and adhesion with the substrate will be better. Yes. How we can control the particle size distribution? The particle size distribution manufacturer control the PSD through grinding, means the grinding parameter and the classifier parameter. This will I'll discuss later. This just you have seen the laser diffraction machine for the particle size. There is another method. This is very good sieve analysis by Alpine Jet, air jet sieve. That video is also coming. So these are the factors affecting the properties of the powder. The milling parameters means ACM parameters. The grinder speed, the feed rate, airflow rate of the mill. जो डस्ट कलेक्टर के बाद में ब्लोअर फैन होता है, वहाँ से आप एयर फ्लो रेट कंट्रोल कर सकते हैं. Then cyclone separation and strongly influence the particle size. Then formulation, definitely the resin, the choice of the resin, the choice of the fillers. Choice means the particle size of the fillers, that is also very important. And the choice of the resin for the better flow and for the flow any smooth finish, the resin is different. And for the structure and texture, resin is different with slightly more viscosity should be there. Then of course, after grinding, we sieve the powder so to separate the coarse powder from the required particle size. So that sieve analysis is there. This especially, but this photograph I especially put over here. Normally ACM have only one cyclone. This is having two cyclones. One is here and another here. The benefit of this, the fine powder which is going to the dust collector, you can collect with the secondary cyclone that you can reuse on the extruder because it is of single color, no mix of the color. And the required powder you can get on this sieve. These are some spare part between the sieve. You know better all. This slide is very important because the sieve analysis, it is done from 32 micron to 100 micron. The data is here written. It should be in between this parameter. This is what is principle of Alpine air jet sieve. This is a testing method. This is not computerized. The Melbourne instrument was computerized system. This is through vacuum cleaner. The Alpine air jet sieve is a unit that uses air generated from the vacuum to separate the particles. Can I have a video, please?
So you're looking into refining or buying an Alpine, but something important to think about is, what sieves are there? Will they work? Will they better my operation? Well, stick around and I'll tell you everything you need to know. Hey there, my name's Andrew Kotlar, and sometimes regular sieves just don't cut it. If you're struggling with heavy particle agglomeration, the Alpine E200 LS can revolutionize your process. But it all comes down to sieves, right? Well, W.S. Tyler has been in the particle size analysis industry for over 110 years, and is here to make sure you have the best particle analysis setup possible. That's why in this video, we'll go over what an Alpine E200 LS is, the benefits of an Alpine air-jet sieve, and the sieves used on an Alpine. An Alpine air-jet sieve is a unit that uses air generated from a vacuum to separate particles. After placing the test sieve in the air-jet, a nozzle rotates 360 degrees while using air to push the particles around. The air-jet is very useful with particles that agglomerate. Since the air-jet pushes air through the sieve, the particles collide with the plexiglass lid, which disperses them. This allows the smaller particles to fall through the mesh opening. And like the goal of all sieves, only the larger material will be left on top after the air-jet sieve finishes its cycle. One of the benefits that separates an air-jet sieve from traditional gravity-driven test sieve shakers are that the air-jet sieves can be connected to a scale unit. You can weigh your pre-batch sample before you run your material, and once you've collected this info, you can run your test. This will provide you with your new sample distribution, which you can weigh on the scale to get the new sample weight. Then you can easily export that to your network, to a printer, or store it directly on the Alpine for later analysis. Another benefit of the Airjet Sieve is accountability and traceability. The Alpine only operates when each user logs into an account to run a test on the unit. This test is then saved and recorded under that user's name. This has become significantly important in the pharmaceutical industry to be able to trace approved analysis back to the user. The Alpine Airjet uses specific test sieves that you can pre-program to each type of material you test in your lab. For instance, if you run charcoal or limestone through your sieve shaker, you can have a preset for each material to remember the exact settings and levels you need for the material. Like I said before, maybe the biggest reason for using the Alpine is for agglomerating material. If you're comparing the Alpine to a regular sieve shaker, the airflow inside an Alpine does a much better job at separating individual particles that tend to agglomerate compared to the simple rotate and tapping motion from a sieve shaker. The Airjet Sieve E200 LS has specialized sieves with pre-programmed RFID chip technology. The RFID stores the mesh size, number of uses, and serial number. They are 200 millimeter in diameter, their overall height is 1 inch, and the depth to the cloth is 7/8 of an inch. Stainless steel sieves from 20 micron down to 4,000 micron with RFID technology eliminates potential contamination and saves having to manually input the sieve mesh width every time. But you can also use a standard 8-inch test sieve without an RFID chip if you purchase the compatibility adapter. The standard sieve is 200 millimeter in diameter, the overall height is 1 3/4 of an inch, and the depth to the cloth is 1 1/8 of an inch. Thanks so much.
So this actually हमने वीडियो इसलिए यहाँ पर लिया हुआ है बिकॉज आई कैन शो यू समथिंग, अदरवाइज यहाँ पर इंस्ट्रूमेंट लाकर उसको दिखाना तो थोड़ा मुश्किल था. नाउ these are very important parameters. The key milling and separation parameter, the ACM mill basic, the system widely used due to compact print, this air classifying mill. The important thing is the screw feeder speed and main mill linear speed. This is linear speed, actually you have to convert. Normally it is rotational speed, RPM. So the airflow, these are the basic parameters. Then main mill, the higher linear speed, higher breakage, fine particles. And if lower linear speed, definitely lower RPM, so coarse powders is there. This is a equation to convert rotational speed into linear speed. This is not very important, but definitely when जब आप लोग पाउडर कोटिंग के ACM को यूज़ करते रहते हैं तो इसका जो मेन डिस्क है वो धीरे धीरे घिस जाता है. अगर आप सेम RPM पर चलाते रहेंगे तो उसका जो पार्टिकल साइज है वो आपको प्रॉपर नहीं मिलेगा. सो एट दैट टाइम this equation helps. Then the classifier and gap between the classifier pins and the lid of the ACM where the chips are grounded. It is very typical, it should be 2 to 3 mm. If it is too large, more than 3 mm, suppose 5-10 mm, the powder will be coarse. And if it is very low, so it will very excess fine. And sometime your powder chips gets soft, so it may clog the mill also. The higher classifier speed increases centrifugal forces, preventing coarse particles. So again and again, the coarse powder particles will come into grinding zone, and when it gets the proper particle size, it will come up. जितने भी हमारे ACM है, you know it is total grounded powder is conveyed from milling zone to the dust collector through pneumatic. जो हमारा लास्ट में blower लगा हुआ वो suction करता है पूरा. Then feed rate is also very important. The feed rate controls the material hold up in the grinding zone. If it is very high, it will make fine powder. If it is low, it makes coarse powder. देन मिल चैम्बर एंड मटेरियल टेम्परेचर। जैसे आप लोग सभी जानते हैं जो समर में स्पेशली हमारा जो मिल टेम्परेचर है वो अगर इंक्रीज होगा तो जो हमारे चिप्स हैं वो मेल्ट हो जाएंगे। सो द टेम्परेचर ऑफ द ग्राइंडिंग जोन इज मेंटेन विद द इनपुट ऑफ चिल्ड एयर, चिल्ड एंड ड्राई एयर। सो एंड स्पेशली जो आपके एक्सट्रूडर से चिप्स आ रहे हैं, द chips temperature is also very important. It should be below 30 degree centigrade. So airflow and cyclone separation and rotary valve sealings. जितने भी हमारे ACM में पाइप्स हैं इनको हम लोगों ने फिक्स करते हैं ओ रिंग लगाकर या किसी से। अगर वहाँ से गैप है, if gap is there, so again the powder will not go up, so powder will be fine, and if gap is okay, so you will get the required particle size powder. So excessive airflow also very it is airflow means air suction generated by blower. So if it is more, so you will get coarse powder, and if it is a less, you will get fine powder. Then same cyclone में जो आजकल तो flap portion चालू हो गया है, butterfly valve, but sometime it is a cyclone rotary airlock is also used. So उनमें जो gap है, अगर वहाँ से air suction है, leakage है, तो again you will not get the proper particle size. So conclusion is, it is not okay. This is the conclusion. The keep D10 above 10 micron. Below 10 micron, very less powder should be there. Then D90 should be, any more than 90% should be below 90 micron. The optical, this is very important, the optical D50 is the average particle size. It should be 35 to 45 micron. These are some basics. कैसे mass को micron में convert करेंगे. So just to calculate mass, divide 14,900 by micron value, you will get mass size. This is very important. सेम साइज की जो सीव है आपको उसमें सेम बेटर रिजल्ट भी मिल सकता है, नहीं भी मिल सकता है। कैसे? जो हम लोग मैश साइज बोलते हैं, सपोज दिस इज 120 मैश, सो 1 स्क्वायर इंच में 120 पोर्स होने चाहिए। पोर्स फाइबर से बने हैं, उनको क्रॉस करके। सपोज आपके फाइबर का डायमीटर बड़ा है तो आपके जो पोर्स है वो छोटा हो जाएगा, और अगर वो थिन है बड़ा हो जाएगा। यू कैन नॉट कंट्रोल। सो सीव वेदर वायर मैश और क्लॉथ सीव शुड बी फ्रॉम स्टैंडर्ड मैन्युफैक्चरर। दिस इज वेरी इंपॉर्टेंट। थैंक यू। दिस वॉज अबाउट फिल्म।
Can we give them a big round of applause? Come on, everyone. So now it's a time to call up on the stage Mr. S.C. Jain. Can we have Mr. S.C. Jain in between us for showing a small gratitude towards Mr. Kuldeep Verma ji. S.C. Jain ji, अगर आप हमें सुन पा रहे हैं, so please join us on the stage. I will repeat again, Mr. S.C. Jain, if you are able to hear me, so please join us on the stage. All right, so now I would like to invite Mr. Mohit Dubey ji from the Premium Coatings. Mohit Dubey ji, अगर आप हमारे बीच available हैं, so please join us on the stage. Can we all clap together for the Mohit Dubey ji? Come on, everyone. So now it's a time to showing us small gestures towards Mr. Kuldeep Verma ji. Congratulations, sir. And thank you so much for being a part towards our 4th edition of Powder Coating Conclave and Exhibition 2025.